Stop sharing. So our next speaker is Jeremy Jones from the CHARA array, who will tell us about remote operations and data access. Are you there?
Hi, can you hear me?
Yep, we can hear you fine, and we can see the slides.
Excellent. Hi, everyone. I'm Jeremy Jones. I am the data scientist at CHARA, and I'll be talking about the remote operations and how to access CHARA data. So here is a nice image of the CHARA server that's hosted here at Georgia State in Atlanta. And on the server, we have 4 virtual machines, the remote observing machine, the data archive, the remote data reduction machine, and our database portal machine. So here's a nice image, a screenshot of the remote observing machine in action. This is a bit outdated now, but it's still, the principle is the same. Got some nice fringes going on over there. So the way this works is we have installed all of the interface software on the remote observing machine in Atlanta, and it talks to all of the servers up the mountain through an SSH tunnel, and then the user will connect to the Atlanta machine using VNC to see all the graphical interfaces, and that way we're not, using up a whole lot of bandwidth up and down the mountain, because that's limited, and all the bandwidth is, just needed between the observer and Atlanta. So here's some statistics on remote observing usage. So this is showing the fraction of observing nights that were done remotely since we sort of went public with the remote observing machine back in 2018. The black line shows all remote observing, the blue line is open access programs only, and the red line is internal programs, and the gray areas are periods where we had various closures. So since we went online, 61% of nights have been done remotely. 46% of all nights are internal remote programs, and 15% of all nights are open access remote programs. So this is just going to show the closures here. So we had some time closed down for the initial AO installation, and then our normal wintertime closures. And then, of course, COVID lockdown and the Bobcat fire, which made 2020 a very fun year. But yeah, so before the global pandemic happened, we had gotten to a stable, maybe 1/3 of our time being remote. And then, of course, at the height of COVID, we were 100% remote. And then now we're starting to make exceptions for engineering programs. So here is a view of 2021 only, the same sort of thing here, with black being all remote nights. So 86% of all nights in 2021 were remote programs, 62% internal remote, and 24% open access remote programs. So in 2020, the remote observing was very popular, but it was also mandatory. And then in 21, it was required, but we allowed some exceptions. And then 22, it's still required to remote observe for now, but engineering you have to do engineering in person. So moving on to the data archive. So the idea with our CHARA Atlanta Data Archive is to host all CHARA data in one central location, consolidating all the different databases from all the beam combiners. So our overall data policy is that CHARA data are public, except for, and this is the big exception, is new data is not public. So there's an 18-month proprietary period. And then, of course, student thesis data is protected, and long-term survey data is protected, but otherwise, old data is publicly accessible. The primary way you access this data is through our remote data reduction machine. So here's an image of some climb data being reduced. Nice little waterfall plot here. Yeah, so the data reduction machine is linked to the archive. So the idea being you've got access to the raw data. You don't have to download your raw data. All of the reduction software is up to date. So you can just log on, reduce your data, and download the final product. And yeah, so it's the same. You access this using the same VNC protocol that we do for remote observing. So doesn't matter if you have Windows or Mac or whatever. We also include some, have installed some analysis software like Candide and PMOI Red in case you want to use that. And if there's any other analysis software you might want to use, then you can talk to me and we'll, we can work something out. Yeah, so I've also put together the CHARA online database portal, which lets you see what data are in the archive. And the basic idea here is we've got the raw data on the archive, which is accessible on the data reduction machine. And we read the headers of all the raw data and put it into this SQLite database file, and which we can then upload that information to JMMC, OIDB, and OBS portal. And we've also got it displayed on a website that then I'll demonstrate this in just a minute, but the idea is that you can easily search for just what is in the archive. Yeah, so the structure of the database file is there's a table for each beam combiner, and each of these tables is just the raw header information, no corrections, no cleaning, no anything, just what is in the header files of the raw data. And then we combine this into one table, the all CHARA table, and the idea, and then we do some cleaning up to make it all standardized so it can all be easily searched through. So let me just take you to the, that's what I want. Yeah, take you to the database. So go to chara.gsu.edu and then observing database, CHARA online database portal. And then, so you have access to all of the individual beam combiner archive, not archives, but databases, but we'll go with all CHARA, because again, that's the standardized one. So you can put in star name, you can search by date. When you search for a star, it will use this search distance to search search for coordinate, any objects that are within that coordinate range for the star you put in. And then there's various things you can display, and you can select for beam combiner or PI. So let's do a quick search for HR 8799.
2 minutes.
Thank you. So yeah, you see all this PAVO data and a little bit of MERCX more recently. So back to the presentation. So the last thing I want to talk about is the CHARA Seeing Reviewer. So this is a new tool. So when you're on the data reduction machine and you want to see what the seeing was like, or in fact, any information that's stored in the wavefront sensor logs, because the seeing is coming from the wavefront sensor logs, then I'm going to just see if I can demo this real quick. Where did that go? That window. So seeing reviewer. So this is a view of my log into the data reduction machine. So select all the telescopes, and then there's various smoothing factors you can choose. I'm doing last night's log. So it's a bit messy because this is just all the raw information from the wavefront sensor logs, but you can zoom in and see how the seeing is changing over the night. So yeah, last night wasn't great, but can't win them all. Yeah, so that's all I've got to talk about. So if there are any questions?
Any questions in the room? I don't think there are any questions on the chat either. Jeremy, do you keep any logs of how many accesses you have to the archives?
No, so the way basically what happens is you sign up for an account for the data reduction machine, and I'll put that the link for that in the Slack channel, and then you have free access to the archive. Well, with the exception of the proprietary data. So I don't keep track of that now.
Okay, I'm just wondering if you had any indication of, say, whether people prefer to go to OIDB or to use the CHARA interface?
No, and I see a question in the chat from John, and right. So the CHARA metadata, the plan is to share it automatically with JMMC, but that has not been done yet. Partly the motivation for putting together the online database portal, the actual online bit didn't take too long to do. It was the underlying consolidated, cleaned up database that was the important bit. And so it is from that we can share with JMMC. And I'm still putting some final touches on that before that becomes more automated.
Yeah, just wanted to ask one other thing with my OI Fits hat on. What's the status of OI Fits version 2 support for all the CHARA pipelines?
That is a good question that I do not have the answer to. So basically how each instrument handles their data product is up to them, and I just take what the raw data is and make it available.
Thank you. Right, can we thank Jeremy again, please?